Alrighty, Unit 2, Lesson 1. Okay, page 46 is your skills maintenance, so pause this video, go ahead and work on that page. Okay, so for our skills maintenance, solve the basic and extended multiplication facts. Okay, so just filling in the blanks. So 4 times 6, there we get 24. What times 3 is 24? 8. 7 times 8, 56. 5 times 4 is 20. 9 times 7 is 63. 4 times 8 is 32. 40 times 6 is 240. 30 times 8 is 240. 70 times 8 is 560. What number? 8. Okay, 4 times 50 is 200. What times 9 is 630. 70 times 9 is 630. And 80 times 4 is 320. Okay, so those are some facts that we should be able to get. Now, today, our objective, use variables to represent a single value or a range of values. Okay, so up to this point, you've seen a lot of things like this, like what plus 8 is 15. Another way we can write this is saying x plus 8 is equal 15. We're just representing that blank with a variable now, okay? Variable, typically we use letters like x, y, and z. Those are 3 common ones. Now, it can be anything, a symbol, okay? Commonly use x, y, and z though. So you will see us use that a lot. Now, so using that blank line again, we're just using a variable now. Okay, so identifying general patterns now. So we got 5 plus 0 equals 5. Another one we're going to say 10.7 plus 0 equals 10.7. Okay, 150 plus 0 equals 150. So what we're going to be doing here is we will need to see what is happening on each one. Every single time we're saying plus 0. Okay, but then you also notice we have a value. That value is varying. Okay, we're going to use a variable to represent those values that are varying. And what you can tell is that those values are exactly the same. Okay, so the way we're going to write this general pattern now, the first values we're changing, we're varying, so we're going to use a variable to represent that. The plus 0 never changed, and it always equaled whatever that value that was varying. So x plus 0 is always equal to x. Okay, so that is how we're going to write the general statement for that one. Okay, moving on. 6 minus 6 equals 0. 1/2 minus 1/2 equals 0. 1,253 minus 1,253 equals 0. Okay, what you're noticing now, or what you should notice, is it always equals 0. Okay, and we're always taking that value minus that same value. Okay, so again, the ones in red there are the things that are varying. Okay, so let's go ahead, let's use a different letter. Let's say M. Okay, we're going to let those numbers that were varying be represented with M. And we are always subtracting that same number, and it always equaled 0. Okay, so our general pattern in this case is M minus M is equal to 0. Okay, so the next one, 3 times 1 equals 3. 1/2 times 1 equals 1/2. 1.35 times 1 equals 1.35. Okay, so what I'm noticing is that we are multiplying by 1 every single time. So when I write this general statement, it's always going to be something times 1. Okay, now the things that were varying were those first values, So we're going to say 1. The way we're going to represent all those values then is with a variable. Let's go ahead and let's use x again. Okay, we're taking that value times 1, and it always equaled that same value, okay, which we represented with x. So x times 1 is equal to x. Okay, so another way we use variables, we got x plus 9 equals 16. Okay, so now we're going to see, okay, what is that value that I could put in place of x? Okay, so what plus 9 equals 16? In this case, 7 plus 9 is 16, so we're going to say x equals 7. Okay, because if I take that value of 7 here, put it in place of x, that's saying 7 plus 9, which is 16. Okay, so x plus 0 equals x. and we're saying x can be any number, okay? It's called a variable, so those numbers can vary. Okay, so go ahead, apply skills, page 47. Go ahead, work on that, and pause the video. Okay, coming back, solve the multiplication facts. The missing part has been replaced with a variable. Okay, so finding what that variable is equal to. Now, when we are doing this, okay, so like on number 1, 4 times 7 equals m. When we're writing the answer to these, we need to be saying m is equal to whatever that value is, which in this case is 28. Okay, what times 6 is 30? X is what our variable, so what x times 6 is 30? X is going to equal 5. Okay, this one we're saying y equals, and then 5 times 4 is 20, so y is equal to 5. This case, s is equal to 4. Number 5, t is equal to 5. In this case, z is equal to 7. In this case, k is equal to 25. And in this case, b is equal to 2. Okay, so finding those general patterns now, again, go ahead and find what's exactly the same every single time. 1. 1 is a thing that does not change. Okay, so we're saying 1 times something, okay, and that something is 775.8 and a quarter, and it's always equal to that. Okay, so those are the things that are varying, so that's what we're going to represent our variable with. So let's say x is equal to that x. Okay, in this one, plus 0, plus 0, plus 0. Okay, so that thing does not change at all. And we're taking that some value, and it's always that same value on the other side. We're going to represent those values with, let's say y this time. Y plus 0 equals y. Okay. Now, one thing I've noticed, some people put y here and then x here. That's two different values. Y, these values are exactly the same, so we have to represent them with the same variable. Okay, here I'm seeing equals 1, equals 1, equals 1. Okay, and it's always that value divided by that same value. Okay, quarter divided by a quarter. Okay, and it's always equal to 1. Okay, so we got always equals 1. And those values on the 4, quarter, the 234.9, those are the things that are varying. So let's use a variable to represent those, x, and we're dividing by that same value. So x divided by x equals 1. Number 4 equals 0, equals 0, equals 0. Okay, kind of the same idea as the last one, except now we are subtracting. So in this case, let's say x minus x equals 0. Okay, there's your apply skills for lesson 1. Okay, problem solving, I will use a pattern cards to develop a vertical strategy for identifying multiplicative patterns. Okay, so in this one, I went in and I entered the number of circles, number of stars for each card. So now we need to look vertically. So vertically, remember, is up and down. And we're talking multiplicative properties, so multiplying. Okay, so I'm looking, is there a good way to 2 times something to get 3? I don't see a good one. Okay, it'd be 1.5. In this case, times 2. This case, times 2. This case, times 4. In this case, times 2. So what we're trying to find is a pattern. Which 3 cards are related? Okay, I notice in card 2, 3, and 5, we're multiplying by 2 for all of those. So those ones are the ones that are related. Card 2, 3, and 5. We're multiplying by 2. That is the reason why they are related to each other. Okay, so page 48, problem solving activities. Pause this video. Go ahead. All right, so problem solving activity, I've gone through and I've went through every single one and entered the number of x's and the number of o's. Okay, so going through, I see times 2. Okay, in that case, that would be 2.5 times 3 times 4. That's not a good one. Times 1 times 3. Not a good one again. Times 3. And then not a good one again. Okay, typically when you don't see a good one, you're not going to use those ones. Okay, so which cards are related? I see 3 different cards where I'm multiplying by 3. card number 3, card number 7, and card number 9. Okay, so those cards are related. Cards 3, 7, and 9. What is the pattern between the X's and O's related to the cards? Okay, so X, we're taking the number of X's times 3 equals the number of O's. Okay, so again, in these ones, when you see these cards, you're looking for that multiplicative property. How are we getting from X's to O's, or vice versa? Because I could say the number of O's divided by 3 equals the number of X's. Okay, it's the same thing. All right, that is lesson 2. Make sure you complete your lesson 2 homework. Have a good day.